why don't we just say 1,000 cubic inches? So I'm going to plug 1,000 into here to get our cost, okay? So I'm plugging the number 1,000 into suppose my volume has to be 1,000. So 2,000 divided by 5 raised to the 2/3 power. I get a cost of $814.33. Okay, assuming that it was $1 per square inch, which is really too expensive for glass, but. Okay, so, and assume that it was $1 per square inch of glass. All right, so those are two assumptions. All right, how to test that that's a minimum cost then? I'm gonna go back to my relationship that x equals y and z equals 5/2 of that, so that gave us 5/2 x cubed equals volume. And I want my volume to be 1,000. So x is 2,000 divided by 5. You do that. Approximately 7.368 inches. So then y would be the same thing, and z would be 5/2 times that, or 18.42 inches. So it'd be a really tall aquarium. So then plug in something close to these, but we still want to stick to our constraints. Our constraint was that, our constraint is that 5/2 x cubed equals, this is now my constraint. Okay, so I want to plug in something close to these values, but still fitting. Well, my constraint is that the volume has to be 1,000. So keeping the volume equal to 1,000, pick some numbers that are close to these, but still satisfies this. So what if x was 8 and y I made 7, then 1,000 divided by 56. Okay, so I'm going to make x 8, y 7, and if that's the case, then z has to be 17.857 approximately in order for the volume to still be 1,000. So now use these in the cost. Okay, use 8, 7, 17.857 in the cost function and see what we get. Go back to our cost, so 5 times 8 times 7 plus 2 times 8 times 17.875, or 8 times 7 plus 2 times 8 times 17.857. And I get $851.42, which is higher than the 814. Okay, so that's indicating it. I mean, it's not really a proof, but it's indicating that we've hit a minimum. Okay, the way the question was asked, though, they did not give us a specific volume. They just said it was some constant. And so this is really about as far as we could go with the way the problem was asked. What I was doing here was just trying to give us some concrete numbers to see that following this does give us a minimum cost. If you took these and instead of plugging in here, you plug in here, you get that same thing.